This is a drone. Here is another. This is a beach. And this is the ocean. After the BP oil spill in 2010, scientists came together to study how contaminants like oil move from deep water onto our beaches. At first, you might think it's pretty straightforward. If you pour something offshore, like this pink dye, don't worry, it's EPA approved and doesn't hurt the environment. It will just end up on the beach, right? To answer this, a group of scientists from the University of Miami, the Naval Postgraduate School, and Delft University went to Destin, Florida to conduct an experiment using drones. Here's how it works. First, they place sensors up and down the beach in the area of interest. Next, they release a specific amount of dye offshore from a boat in different patterns. Once the dye is in the water, the first drone is launched and sent out to a specific latitude, longitude, and altitude over the water. Once it's on station, it starts recording high-definition photos with its onboard GoPro. Here comes the tricky part. Since the drone's batteries only last for about 10 to 15 minutes, it's impossible to get continuous coverage of how the dye moves. But what if you have two drones? With two drones, when the one in the sky starts running out of juice, the second on the beach can be launched to relieve it. With this configuration, they are able to monitor the dye without missing anything. Pictures from the drones offer a lot of important information about how oil might make its way to the beach. When you add all the photos together in a sped-up time-lapse video, it becomes clear that this process isn't as simple as we might think. Because the GoPro has a fisheye lens, the images are distorted, making it hard to measure how far and how fast the dye moves. To fix this, the distortion is removed. Then, using what are called ground control points, or points in the picture that we know the GPS position of, the image is georectified, a fancy way of saying that it's transformed so that one pixel length represents the same distance in all directions. Georectified images are very valuable. With them, scientists can accurately measure how much the dye spreads, how fast the currents are moving, and much, much more. Not bad for a couple of little robots. To learn more, visit carthe.org.